Hello everyone. Just wait for a while. We are waiting for the participants as they are joining. We'll start in a minute. So once again, good afternoon everyone, and a very warm welcome to this webinar hosted by Center for Science and Environment. I am Hariprakash Hemanshi, Deputy Program Manager at CSC, and it's a pleasure to have you all with us today. During this webinar, as the name suggests, we will explore some of the critical but often underemphasized aspect of sanitation, that is the effective operation and maintenance of fecal sludge and treatment facilities. We have a great lineup of speakers who will share their experiences. But before we begin, I'll give you a quick look of today's agenda. We will start with the opening remarks and introduction to the webinar objective. Then we will further start with the focus presentations on various themes, starting with understanding SOP developed by Uttar Pradesh and moving towards the lab perspective on the performance of these facilities. And then after that, insights from ground experiences on long-term sustainability of these treatment systems. Towards the end, we have a sessions for slot for the question and answers. So please put your questions in a Q&A box, and we will take them and towards the end of the sessions. So today we are joined by sector experts, government officials, and researchers from Asian and African countries. So that brings a rich mix of experiences and perspective. Now to take this webinar forward, I would like to invite Mr. Subrata Chakravarti, who is the Director of Water Program at CSE, to further moderate the program, moderate the webinar, and set the agenda for today's discussions. Mr. Subrata has more than 22 years of experience working in social and development field. He's passionate about clean water and safe sanitation. He has long experiences of working with the government in shaping policy interventions and policy implementations, both in urban and rural areas. He has also worked with the international development organizations like World Bank, IFMI, and corporates like PwC. Currently, he's leading CSC's water program. Now I'm handing over to Subrata to further lead us into the main discussions.
Thank you, Hari. I'm audible. So good afternoon, everyone, and thank you for joining this technical session. And I'll quickly take you through the CSC, its water program, and context of this webinar. Now, CSC is a non-profit society, and it is established in 1980s. And our main work is action research, advocacy, capacity building, and cross-learning, and also definitely technical support to various organizations, government and non-government organizations. And our institution aspires to bridge the gap between information and knowledge to public awareness. And our main work is to influence public policies and practice for sustainable development to promote sustainable development with equity, participation, and democracy. We, as CSC, because of our own work, we also awarded with a couple of internationals and national awards, including Stockholm Water Prize in 2005, Indira Gandhi Prize for Peace, Disarmament, and Development in 2018, and so on. And Center CSC also works closely with the government organizations and government ministries. And CSC has Anil Agarwal Environmental Training Institute, AAETI, which has state-of-the-art training institute and the living laboratory. Next, please, sir. And in CSC, for research and advocacy, we have a couple of verticals which works on air pollution, mobility, climate change, industry, environment education, sustainable food systems, municipal solid waste, and definitely water, wastewater, and sanitation program. And our work is communicated to the general people through our Media Research Center, our Down to Earth, which is English and Hindi and digital editions of it, and also websites and e-newsletter. And we have, as we have mentioned, that pollution monitoring laboratory is there in AETI campus. And we have AETI for building capacities of various government and other stakeholders in the sector. Next, please. In our water program, we work both in urban and rural areas, and we have water, wastewater vertical, and so also we work closely with the Uttar Pradesh government. In the water sector, our focus is water sensitive urban design and planning, and groundwater recharge, rainwater harvesting, and protection, rejuvenation of water bodies, and water efficiency promotion. In the sanitation part, we work in the Faecal Sludge Septage management domain, city-wide inclusive sanitation, grey water management, decentralized wastewater management, and definitely reuse of treated water and biosolids. In UP, we closely work with the Department of Urban Development, and we support the government in scaling up FSSM, and which is closely associated with Amrut 2.0. And we have a total team of 15 members of diverse background. And capacity building is one of our focus areas, and through which we build capacities of thousands of practitioners and policymakers over the last couple of years. Next, please. And our program has close association with various development institutions across the countries. Next, please. And whatever we research, we come up with publication. Those publications are available for public, and all these publications, this is a couple of them, and all the publications are available in our website for easy download. Next, please. And coming about today's webinar, so SDG 6 objective is to sustainable management of water and sanitation. To achieve this sustainability, it is not only required that infrastructure is created, but most important is that infrastructure is functional, and these are consistently maintained. So for the aim of the objective of today's webinar is that the critical importance of proper operation and maintenance of FSTPs and co-treatment facilities is very important. And we, in our session, we will also showcase the standard operating procedure that CSC has developed for the state government of Uttar Pradesh, and also how these SOPs can serve as a valuable reference tool for across the states, across the globe, and other sector experts from CDD and IIHS will also share their on-ground experiences today here. Next, please. So urban areas across India and globally are adopting FSSM plants as a sustainable alternative to conventional wastewater systems. In India, Uttar Pradesh, Odisha, Maharashtra have emerged as front runners, and also other countries globally, to mention a few, just Bangladesh, Ethiopia, and many other countries are constructing and also operationalizing various FSSM plants. However, ground infrastructure, the key priority is to have proper O&M in place. And now, as I told, CSC has developed a document which we considered that could be critical for many of the countries, many of the plant operators. And our practitioners from CDD and IHS have also joined today to share their field experiences so that we have sharing of learning across states here. And today's session aims to empower practitioners with practical tools for long-term FSTP sustainability. Now, with this, we move to the thematic presentation. This is a very technical session, and the first theme is SOP for O&M of FSTP and co-treatment plants of Uttar Pradesh. And here, Harsh Jadhav from CSC will briefly describe the structure of the SOP document and why this could be an important reference document for professionals and for who are working towards sustainability. Harsh Jadava, Manish Mishra, and other colleagues of CSC have worked directly to create this document. Harsh is program officer at CSC, who is an environmental enthusiastic and having more than 8 years of experience working in the waste sector. At the CSC, he supported Bijnor city for creation and setting up of co-treatment units, and he is also a trainer on SFD part, and currently he is posted in Lucknow, and he is supporting the state government along with his colleagues there. And he is one of the person who developed this document. Thank you. Harsh, is to you, over to you for sharing your insights.
Good afternoon, everyone. A warm thank you to Subrata sir for this kind introduction. I'm delighted to present today on standard operating procedure for operation and maintenance of co-treatment plants and Faecal Sludge treatment plants of Uttar Pradesh. The document prepared by Center for Science and Environment for Department of Urban Development, Uttar Pradesh. So in this presentation, I will walk you through the current status of FSSM infrastructure in Uttar Pradesh. What is the status of FSSM? What is the technical diversities that has been observed in FSTPs and co-treatment units? What is the context for preparing this standard operating procedure? What are the salient features of SOP? What are the precautionary and safety measures that has been used in this SOP as a feature? And then in the later part, how this SOP can serve as a reference model for beyond state at national and global stages also. So when we talk about FSSM and Uttar Pradesh, it started its in pure color when Center for Science and Environment came up with a study of 66 cities of Uttar Pradesh across all its geographies, and an alarming situation was understood by the stakeholders that FSSM is a great a conscience of for FSSM was understood. So with this alarming situation was followed by a tender of 59 FSSM projects in Uttar Pradesh by the stakeholders, by the government of Uttar Pradesh. In that, 41 of the projects were completed by 2023 due to some delays thanks to COVID-19. And in 2024, out of these 59 projects, 58 projects were commissioned. Currently, we have 39 FSTPs and 20 co-treatment plants. All these coming under different funding agencies like Amrut, State Mission for King Ganga, and City 15th Pay Commission funds. So let's move forward. If we understand how FSTPs have come across, there were around 11 contractors who came up with their own type of treatment configurations, a vast variety of configurations. And when CSC team entered into the ground, we observed around 15 to 20 configurations of FSTPs. But later we tried to streamline this configuration into 4 broad classifications, which I'll discuss in the next slide. Overall, there are 5 types of capacities that has been observed in Uttar Pradesh. One is 32 KLD, other is 25 KLD, 12 KLD, 10 KLD, and 6 KLD. Out of these, 35 KLD is the most one, that is 32 KLD is the most one, that is 35 in numbers. Apart from this, the important thing to notice here is that none of the contractors provided a standard operating procedure to the ULBs while handing over the treatment infrastructure. Let's understand what are the different type of technologies that has been used. Broadly, we have classified them into hybrid and nature-based systems. Under hybrid systems, we have MBBR and SBBR technologies coupled with other nature-based units like ABR and constructed wetlands or planting table filters. And in the nature-based units, we have especially the ABR followed by constructed wetlands and the tertiary units. Similarly, the case for the co-treatment plants, we had 6 contractors who came up with their own different types of technologies and configurations. We streamlined it into 5 different configurations. Overall, we have 5 capacities, 5 types of capacities: 100 KLD, 75 KLD, 50 KLD, 25 KLD, and 20 KLD. 25 KLD co-treatment plants are the most in number, that is 11. And here, as similar to what I told in the case of FSTPs, none of the contractors gave the standard operating procedure for the reference or for operation and maintenance. So these are the broad classification of co-treatment units in Uttar Pradesh. The most common one is the one with the steam chamber, followed by some solid liquid separation, where solid goes to the solid goes to the drying beds and liquid goes under some digestion process at anaerobic tank and pythorate beds. So from the previous slides, we understand what are the basic reasons why SOP was developed. During this time, it was also understood while we were on the ground that there was minimal involvement by the ULB during the tender process and the construction of the FSTPs, due to which there was very low familiarity with the treatment system. And further, as the technologies were very diverse in nature, the operation maintenance was not focused completely by the ULBs, because there was no reference for operation maintenance, as SOPs were not present. Further, as we already know, the government staff keeps on gets frequent transfers. So one staff who has worked with one kind of treatment technology at one city finds it difficult to cope up with the different kind of technology in the different cities, and there is no reference for operation maintenance. Only one SOP was provided at an FSTP, which was also in English, and that was very difficult to understand by the operators, which was also a factor in making a SOP at a centralized level. So all these were is the genesis for creating an SOP at a centralized level. Center for Science and Environment, along with Department of Urban Development, published this SOP document in December last year. It was launched by Director of Urban Local Bodies, Mr. Anuj Jhaji. And then let's understand what exactly is the treatment process. So when it comes to fecal sludge and treatment, fecal sludge and septage, it is a mixture of very vast variety of constituents, solid waste, and many more things. And since there are many constituents, it requires many kind of treatment processes, many kind of systems where multiple processes of treatment. So there are physical processes, there are biological processes, there are chemical processes, there are photolytical processes, and for biosolids there are different kind of other processes. Physical processes could be sedimentation and filtration, and mostly used for the separation of the solids from the liquid part. And it depends on the specific gravity of the solids to get away from the water when any external agent is introduced. Biological processes are the heart of the treatment, and it uses uh, anaerobic digestion process to break the organic matter, anaerobic processes to break the organic matter. Chemical processes are employed at different stages. For example, as I told you, the coagulation is done through the external agent to expedite the process of solid liquid separation. The photolytic processes, for example, disinfection through UV radiations to kill the pathogens in the water, and photosynthesis for uptaking of nutrients for uh, purification of the biosolids part. Now let's understand the treatment stages. In the treatment stages, we can see the primary treatment, secondary treatment, and tertiary treatment. In the primary part, we focus on the removal of solid part. In the secondary part, treatment part, we focus on the removal of BOD and COD and some inorganic materials, nitrates and phosphates. In the tertiary treatment, we focus on the removal of pathogens like bacteria, fungi, protozoa, and viruses. Similarly, in the stress processing units, we do the same by killing of pathogens. Let's move forward. Understanding the treatment chain for FSTPs of Uttar Pradesh. The treatment chain that you are seeing in front is the most common treatment chain that has been used by around 15 to 16 fecal sludge treatment plants of Uttar Pradesh. And all these modules that are included here in the primary, secondary, and treatment tertiary part are included in our SOP. Other than this, there are few other treatment chains that whose modules are also included, and that completes the package for FSTPs. When it comes to co-treatment plants, the most used treatment chain is the screen chamber, followed by screw press for solid liquid separation in the secondary part, and then some kind of treatment is also done for the liquid through digestion and at aerobic tank and pyrethroid bed. The solid part goes to the sludge drying bed, and the liquid part after the hydroride bed goes to the STP inlet for further treatment. Here also there are, other than this, the common one, we have other modules also that were also described in the SOP, which we can see in the SOP here, and it completes the package for the co-treatment units. So some of the features are already clear from the previous slide. We can say that SOP is a one-stop reference for all the FSN projects in Uttar Pradesh and at national level also. It covers the primary, secondary, tertiary treatment. It has been published in two languages, English and Hindi, so it has a wider usability. Special emphasis has been given to sludge processing units, emergency protocols, occupational and health safety units. And before the publishing, it was sent to 10 plus sector experts, 20 plus contractors, and also reviewed by IIT Palakkad and CDD and Saniverse, apart from other than State AMRO Department of Uttar Pradesh. So let's go through an example how SOP has been made, what is the structure of it. So if we see, there is a code called P1, P1.1. This is the code for the photograph we have used for the describing the module. So the module is the screen and grid chamber, and the photograph is taken from the feed. What is the activity happening? We are decanting at the screen chamber. What is the operation that is happening? That is the desludging operator will connect the hose pipe with the vacuum tanker to the opening of the screen chamber and open the valve at the outlet. And then how many times it has to be done? The frequency is mentioned in the here that every trip we have to do it. And what are the precautions one has to take? One has to use gloves, gumboots, and masks to do this process. Similarly, we have secondary unit, Tiger biofilter, second part. biomedia maintenance. Let's take as an example, the activity we are going is biomedia maintenance. So what is the process here? We have to inspect the biomedia for degradation or compaction and understand if the cocoa husk is required for replacement or not. And monthly we have to do it. Similarly, a walkthrough example we can see for the activated carbon filter. What activity we have to do? We have to do check for the pressure of the activated carbon filter and measure if the filter pressure is the difference is more than 0.5 bar or not, and understand this. This we have to check this in every cycle of the treatment. And since it's an electrical equipment, so we have to use our gloves every time we are dealing with the electrical equipment. Similarly, there is a process walkthrough example for the sludge processing units. We have activity, we have module, and we have operation for that for sludge drying beds. And we can see that what are the visual inspections, that activity that we have to do on the field. If there is an operator, the operator has to do some visual inspection for blockages and understand if there is any visible damage or water is at standby or irregularities in sludge layer. And these things we have to do daily. And what are the things which you have to keep in mind as a precaution is, like, we have to wear gloves, boots, and mask at all the places when we are dealing with fecal sludge drying beds. So in here we have compared different type of modules present in the different states of India. As we can see the common most of the modules present in Karnataka, Tamil Nadu, Maharashtra, Odisha, Rajasthan are already present in our standard operating procedure we have prepared here. So the usability of this document increases from here to the national level, and further at the global stages, people who are, or the countries who are initiating their FSSM projects or entering into the tenders, they can take reference of what kind of treatment chains would be perfect for their own context and setting. Another things which we have this SOP offers you is that there are wide variety of safety measures, wide variety of emergency response units we have covered in this SOP. For example, if there is an accidental spillage from the truck at the fecal sludge treatment plant, what would be the emergency response procedure for that? How will you tackle that? Or maybe your sludge drying bed is flooded. So what would you do? What would be the protocol for that? All these have been included in an SOP.
Harsh, you have 2 minutes more. Thank you.
So that's all that covers that has been covered in the SOP, and I have put a link into the QR code. If you want to download this SOP in English and Hindi language, you can download it from the QR code. That's all from my side. Any other questions you can put into the chat. Thank you. Yes.
Thank you, Harsh. It's a brief but nice description of the SOP document. And also you have successfully shared the features and structure of the document. And this document was difficult to develop because in Uttar Pradesh, there is no fixed module of treatment. There is no fixed chain of treatment modules followed across the plants. So all the tendering process was open, and the constructor, the consultants, choose their own treatment module. So that's why for primary, secondary, and tertiary, part of the treatment chain, there are multiple modules. So for each of the modules, Harsh and team have, in detail, they have described what are the actions to be taken both for operation and maintenance, including frequency and safety protocols. That's why we think this document could be helpful for others also, because it has multiple modules covered in the document. Thank you, Harsh. Now I'll request Rajarshi to come. Rajarshi leads our CS's environmental monitoring lab, and the environmental monitoring lab have done rounds of visits to check the quality of treatment in Uttar Pradesh FSTPs and co-treatment units. Here, Rajarshi will briefly share his insight from his study in the UP FSSM plants. So Rajesh is a microbiologist with more than 18 years of experience in wastewater and fecal sludge treatment. And he has also taught at undergraduate and postgraduate levels. He is also AVP R&D at Ganga Basin Limited. He developed R&D systems for biotoilets and fecal sludge treatment. And he is currently leading and director of the Environmental Monitoring Laboratory. He leads research and policy initiatives in environmental management. And he played a key role in establishing India's first fecal sludge management lab. Thank you, Rajesh, and over to you for presentation. Thank you.
Will you be sharing, or I can share my presentation?
You can
see,
you can share, Rajesh.
But someone else is sharing. It's giving me a message. Someone else is send request, so I sent a request.
No, you can go ahead and share.
Yeah, sure. Thank you. Is that full screen now?
Please put it on full screen. Yeah.
Yes, now it's okay.
It's there. It's there. Thank you, Shubhrato. And Harsh, you actually made my work much more easy. But just to start with a lighter note, the picture you have given me looks, appears, but I'm such a serious and such an angry person. I'm not actually. Please. So just to talk about, as they said, that as you work, Harsh, Hari, they were the frontline warriors when they were working in UP in developing and understanding, developing and creating that environment to make the FSTPs work. Behind them, we were some kind of soldiers who were giving them those scientific inputs that based on the engineering design, each of these units, there was a particular output performance they were designed to be, the contractor had claimed to be. We went out to these FSTPs, we collected samples, I'll talk about what we did, and then we tried to understand where, if something is going perfect, how is it going perfect, right? If something is going wrong, if there is a challenge, where is the challenge? Where exactly lies the problem that could be mended up? And that is how this backing up of the lab actually helped. I'm sure Harsh and Hari and every team would say that it helped them to talk to, in a very layman's perspective, the science in a layman's perspective, to make them understand and get the FSTPs working and up and running and improving on their performance gradually. So I wouldn't repeat these slides. These are already some repetitions of what we did in Uttar Pradesh and how Uttar Pradesh has been doing. What I would try to ask you, focus you on is, we did this study in two phases. That was in phase 1, we took up 10 FSTPs and 3 co-treatment plants. And we have already published the report. I'll talk about it in brief. And of course, in the current study right now, we are actually assimilating the reports and trying to come up with an understanding where in this phase 2, we studied some 14 plants, wherein there were 11 FSTPs and again, 3 co-treatment plants. I would try to talk in both the sections, in phase 1, what we found, and phase 2, what we found. And then I would try to conclude in one slide what our observations and recommendations are. Now, these are some of the plants which we did in the phase 1, was Shamli, Amroha, Loni, Modinagar, Hapur, Aligarh, Shahjahanpur, Basti, Deoria, Chunar, and of course, as co-treatment plants at Shahjahanpur, Gorakhpur, and Etawah. Now, more or less, again, I would not spend much time on this slide because the technologies have already been described in you very nicely by Harsh. So I would say the main module, what we found is the dewatering system. It is either a nature-based, like gravitational or decantation, or it was an electrical kind of, or electromechanical kind of dewatering system wherein a screw press was being used. The next phase, of course, once the water and the solids separate out, the liquid goes through a series of either a nature-based series of treatment, wherein the pollutants in terms of nitrogen, phosphorus are reduced, and in terms obviously the indirect pollutants, what we call the BOD, COD, they get reduced. And finally, there is a little bit of polishing of the water in terms of different kinds of filters and final disinfection. In the other modules, there was an electromechanical thing. And of course, these modules differed. Somewhere we found UV disinfection, somewhere it was chlorination, somewhere it was ozonation. So based on that, we tried to talk about it. I'll show you in a graphical representation what it was. Of course, what we studied at the FSTPs was we took the raw fecal sludge that was coming by the desludging operator, that was brought in by the desludging operator. After that, the inlet, what we call, is what we took is the dewatered liquid. After dewateration, the liquid that came up, whether it was a mechanical or whether it was a nature-based or gravitational, we took that, collected that liquid, and we called it to be the inlet. Final, after all the treatment modules, whatever treatment module the FSTP might be having, we took the outlet of the FSTP or the treated water of the FSTP. And of course, separately, after dewatering the biosolids, which is left behind, it is given a separate treatment. And most of the times we saw it was sun drying and open, unplanted drying beds. So that is where we took the biosolids. STP, there was just a bit of addition where the raw fecal sludge was taken, same inlet was taken, which was the after dewatering. Now this dewatered water was actually entering into the main modules of the treatment of the larger treatment plant, that is the STP. So we took that to be the outlet of the FSTP to understand what is entering or how much load is actually going to the STP. The outlet of the STP and the final treated water where the water is being discharged to a water body. And of course, again, the biosolids that is there in the STP, which is mixed with the fecal sludge also. This was our understanding module. And of course, we studied some 10 to 12 parameters in the water and fecal sludge. Right from physical parameters of total solids, volatile solids, suspended solids, to dissolved solids. While in water, in chemical parameters, we try to understand the DoD, COD, the nitrogen, in terms of total gel nitrogen, phosphorus, and of course the microbiological parameters where we try to understand the total coliforms, fecal coliforms, these ones. While in biosolids, we try to understand the nutrient content in terms of nitrogen, carbon, hydrogen. And then we try to study the heavy metals, if there are any. And finally, of course, again, the pathogens, where we study bacterial pathogens in terms of enteric pathogens, as well as the helminths, which is a very big concern in terms of fecal sludge derived biosolids. Now, if I talk about it, this is what we found. This, again, something Harsh has said, it will be just a kind of repetition. There are the different capacities of these FSTPs we had seen. Of course, our understanding of selecting the FSTPs were, we tried to select which were receiving or which were functional based on the capacity on which the plant has been built. At least 20 to 40% it was operational. That is, it was receiving that much of fecal sludge load. We know every ULB comes up with the FSTP, but getting sludge load is the biggest challenge. So we tried to select which were the ones which were forerunner, the ULBs, which were a bit on the forerunner, where they were able to convince the desludgers, or they had the desludgers who would be bringing the plant to an operational condition. As I said, solid liquid separation, there were nature-based ones. There were these mainly the mechanical ones in terms of screw press. Treatment technology, as I said, it was a mix and match of electromechanical and biological, mainly biological, whether it was an anaerobic bioreactor, whether it was a planted gravity filter, whether it was a tiger biofilter, whether it was a moving bed bioreactor. It was a mix of biological and mechanical treatment systems. And disinfection systems also, we found the differentiation. There was mainly chlorination, and there was UV ozonation. And finally, there were some systems which was just a polishing point. Now, to understand what was the treatment efficiency, here I'm not talking about the FS paucity of time. So I'm not talking about the FS. I'm not talking about the inlet, anything. I would just try to speak on the removal efficiency of the design systems. And we see, when we see the COD removal, it varies from 60 to 90% from plant to plant. Or even the BOD removal, if you see, it varies from 50% to almost 90% from plant to plant. If you see the line that is going on the horizontal line, the abstract horizontal line, those are actually indicating you the removal percentage of the CODs plant by plant. While if you see the same on the right is what I'm trying to talk of the first set of 3 co-treatment plants we took up. Again, they are showing you the removal efficiencies of COD and BOD respectively. Similarly, the next important parameter is the organic nitrogen content, is the organic nitrogen and the ammonical nitrogen. And together we call it in science as the total gel-dal nitrogen. Again, if you see, it ranges from plant to plant from merely 38%, 35%, to as low as some plants like Amroha, which was there, of course, merely 23% was being removed. While there were, again, plants like Basti, if you see on the left-hand upper graph, which was removing almost 85% of the 85% of the nitrogen. So the modules varied. The maintenance of the modules actually brought in this differentiation in the removal efficiency of COD, whether it was BOD or whether it was the nitrogen. Similarly, if you see the fecal coliforms, there were certain plants which never complied. The yellow line actually tells you the line of compliance. That is the standard that has been set, regulatory limit that has been set. And if you see, very few of the FSTPs like Aligarh, Modinagar, we found it very prominently failing in most of the parameters, because the biggest problem with Modinagar was that there was no solid liquid separation module. So everything entered into every unit one after the other. So because of which nothing was actually, I mean, it's always, as we do the first step in FSM is solid, separating the solid and the liquid. That is when Modinagar has been suggested very strongly to put up a solid liquid separation module. Similarly, here in the STP also, you see compliance is very rare. Now, why rare? I would come to in my last slide, I will discuss about it, why it is so rare that microbiological parameters fail to perform, although they have been designed with that intent.
Rajesh, 2 minutes more. Thank you.
Yes, sure. So this is again with the biosolids. I would share the slides. I don't have the time to explain you much, but this was again the second. We see the same trend of BOD and COD removal, TKN and fecal coliform removal. When you talk of the biosolids, the moisture content plays a very crucial role. The moisture content, if it's a high moisture content, the more the moisture content left in the biosolids, more are the chances that the microbial pathogens, that is whether it is the helminths or whether it is some certain of the microbial species like Salmonella, they would start growing after a certain point of time. Of course, carbon-nitrogen ratio is the balance to be decided whether it could be used as a soil amendment or not. Fecal coliforms and these are the pathogen content which are related to the moisture content. More the moisture content, more are the chances that they will be present. Less the moisture content, less are the chances that they will be present. However, as we say, most of these FSTPs did perform to a certain level, to the expected level. But the problem here was when we started looking into, we started comparing it with the NGT standards too, wherein most of them failed. Now, let's look back. When these FSTPs were designed, they were designed according to the CPCB standard norms, output standards, or the MOEFCC output standards. The NGT standards, which are far more stringent, they were not designed. So obviously, when we did the comparison, there was this discrepancy where if we see most of in one of my tables, you have seen that most of the times they actually performed according to the MOEFCC. If they failed it at the NGT standards. So not wrong with the design, not wrong with the engineer, not wrong with the thing. If there are certain failures, it is because of tad bit of proper operation and maintenance. Now, let me tell you a simple thing. I mean, dewatering. What we said, it was proper. Every dewatering system, there needs a proper hydraulic retention time. You have to hold it for some time, let it settle down. Then only the separation occurs. Proper separation occurs and further treatment is helped. Mechanical, if you are doing the polymer concentration you are adding and the polymer dosing rate you are giving plays a very crucial rate. We often found that was very vague of understanding within the plant operators. Or if I see the pictures I'm showing you on the right, these will be shared with you. You can always read through. The shared with you on the right, the planted gravel filter is one of the most of them have it, or a constructed wetland, they have it, where the root zones do the treatment. Now, if it's an overgrown PGF, there wouldn't be any percolation of the air, and that's an aerobic process. The plants would die, the microbes won't work, and there would be no nutrient removal. Or even if you keep waterlogged, which is the second picture, what will happen? There would be an anaerobic environment created. Again, smell issues would come up. No nitrogen removal would be done. Phosphorus removal would be done. And what we will land into is the third picture, would be a waterlogged dead PGF. So these are some of the pictographic way, I presume, if we show it to our plant operators and tell them that this is the ideal one. Like if I say in a technical language, planted gravel filter, as they say in an engineering design, that in a 1 square meter area, there should be at the max of 10 to 12 rhizomes of this canna plant. Now, I cannot make this understand to a plant operator who is doing it, but if I can show him an ideal one, actually the second picture which is there, which is showing a waterlogged one, is actually the ideal distance of the rhizomes that should be there. But they have done a higher flow rate, so that is waterlogged. That's a different problem. So these are certain of the things you have to keep in mind. Or in the Tiger biofilters, what plays a very crucial role is the hydraulic loading rate or the hydraulic retention time in the TBF bed of the sludge that is entering. Other thing is the optimum stocking density of worms. There should be, the number I'm showing is 15 to 20,000 worms per meter cube of the vermifilter bed. They should be present. Then only the vermifilter bed would ideally work to remove and convert it into vermicompost. So these are certain of the observations. The slides will be shared with you. And of course, after this, we would have our question and answer sessions, and I would be happy to take up the questions from then on. And these are some of the publications along with the CAC's water team's publications. These are some of the studies which we have been doing in the past few years, specifically related to fecal sludge and understanding fecal sludge. Pan-India, we have done it. And these are all available in our website for you to download and read. Thank you. Over to you, Shubhrata.
Thank you very much, Rajarshi. Thank you for sharing your findings from your team's visit from 27 plants of Uttar Pradesh, and also sharing the treatment efficiency of the plants. It is very difficult for us to check the quality of the treatment without seeing things through the lens of laboratory. So that's why lab visit is so important and so critical, and we understand whether the plant is actually working or not, and whether the treatments are efficient in terms of meeting certain standards. And also you have highlighted the emerging priorities of the plants and the future way forward for some of the cities, some of the plants, what they need to do. And as you have said, Modinagar, the basic thing is not available, solid liquid separation module, but this is crucial to maintain certain standards. And definitely, I know our team is working with Modinagar urban local bodies to install this module. Thank you, Rajoshi, for that. Now we quickly move to the theme 3, which is resource ensuring long-term sustainability of FSTPs, addressing operational challenges and enabling resource recovery. And resource recovery is crucial component of wastewater treatment plants and also for FSTPs. CSC is also doing critical researches on reuse and resource recovery. However, today Girija from CDD will be sharing her experience. Now, Girija is a technical expert on reuse and circularity at CDD India, and she has more than 10 years of experience on resource recovery from used water, fecal sludge, and municipal waste. She represents India on the IWS Resource-Oriented Sanitation Specialist Group and has been recognized at COP27 for her contribution to climate action. Congratulations, Girija. And we'll welcome you to this webinar, and over to you for sharing your experiences and insight. Thank you.
Thank you, Surataji, for the brief introduction. I'll just share my screen. Hope the screen is visible now and I'm audible and better. Yeah.
Yes, visible and audible.
So firstly, I would like to thank CSC for organizing this much needed discussion on sustainability of FSTPs. As we all know, there is rampant implementation of fecal sludge treatment plants across the country, especially in small towns and villages. And hence now it is imperative we talk about it, understand what are the issues and why it is important to develop and follow standard operating procedures. So now let us see what are the field level issues, like what are the O&M issues at the site. And then I'll only talk about the issues at the site, because what to do, how to do is something I think already the Hashji has covered in his talk on the salient features of SOPs. But then I also want to focus on, from the point of operator, how the operation should be, how the design should be, and how it is, the main focus is on how it will actually affect the output quality. Output means treated used water and the treated sludge, and then how can we enable resource recovery. We from CDD, we are a not-for-profit organization registered in 2005. We work across different sectors, from water body rejuvenations to used water management to recently we are also working on water security and urban resilience. Our main design philosophy is what cannot be maintained should not be built. I think that this is so much pronounced in today's discussion. As we all know, predominantly in India, we have drying bed technologies, unplanted drying beds and planted drying beds. And we have other technologies which we have visited across the country. When we talk about operational challenges, it will be, might be because of the poor design issues, because of the poor construction quality or implementation issues, or the poor operations at the site, or it can be because of all of these issues, right? So if you see across this modules, what we have seen is we have seen issues in terms of inclination of the screening chambers to uneven gaps between the bars. Like, these are related to the design and construction quality, to not clearing the grid settled, to broken screens, and to the extremes of screens being stolen. Yeah, so the different kinds of issues we have seen on the ground. And then all this is actually leading to solid waste buildup in the next module, which is the anaerobic stabilization reactor, and hence it becomes non-functional, and then your entire treatment systems goes for a toss. And then we always recommend to do the treatment modules across the modules. We have gravity flow. If it is inevitable, have standby pumps. Having a standby pump seems to be very a small thing, but from the point of operator, if the pump is not functional, then getting it repaired for him will take a lot of time, and then the halt of operations again affects the next modules. Yeah. And then in the plant drying beds, we have seen while removing the sludge, the filter media is also taken out along with this. So we actually recommend to have a kind of mesh above the filter media to avoid this. And then all this will lead to different level differences in the beds. And I think Harsh was also mentioning about having checking for these level differences in the beds. And then the many issues like damage of pipes and all. And to the extreme that we have seen, the standby beds are being used as storage area. And in case of planted drying beds, we have seen issues from the absence of plants to dried plants to growth of excessive plants, like it is not properly pruned, and even like Rajesh was mentioning, not maintaining the plant density, plant spacing, to the random growth of plants in the standby beds. Yeah, and to the extent of broken roof, I would say these are all anthropogenic activities that are still affecting our systems. It's like we have seen the bottles, waste, and debris in the beds, and the roofs are broken, and yeah, and also loading of the sludge to the maximum level, removing the sludge from the PDB before it is reaching the maximum. All kind of issues we have seen at the sites. And then it is in a site where the ASR was overloaded, then it was directly loaded to the settler, and then there was spawning in the, I think this was also mentioned, where there was water stagnation in the PGF, and might be because there is backflow from the collection tank because the treated water is not used. There might be many design issues also, and sometimes they were also watering the PGF, maybe because there were no regular loads, or it is not needed, maybe operator is not trained properly, and there were absence of plants and solid waste was blocking the module. And we have also visited other technologies like thermal treatment technologies, electromechanical technologies, where they actually use the coagulants, polyelectrolytes. And personally, I feel it's still a gray area to understand what is the fate of these coagulants when the sludge is applied to the soil, how it will affect the soil and the plants and the next level health impacts. And also some of the technologies will use you need continuous human supervision to actually run the blowers for aeration and for pumps for sludge distributions. So these are energy intensive, labor intensive. So I mean, actually we need to have the SOPs for different treatment technologies, and that's why it's important that we follow the SOPs. And then when it comes to composting, and like generally if we don't do the composting properly, then there are issues with the leachate, with the odor issues. And then we have seen some good practices also on the ground, like people were using some kind of accelerators to accelerate the process, decomposers, earthworms, and all that. And here I would also like to mention that in Devanali, we have demonstrated different kinds of composting, like the bin composting, window composting, vermicomposting, all kinds of composting. Especially, I think this would be the first in India to have different composting method demonstrated with the fecal sludge. Yeah. So, I mean, if you actually do the composting, I mean, I'll also show, I mean, actually it can be done better and it can smell good. Yeah. So now, as a designer, our thinking or our perspective is all about what should be the HRT level, etc., and all that. We never think about from the point of operator what is for him it is ease of operations. For example, can we think of lowering the screens to screen inlet so that it avoids the splashes, fecal splashes, or hiring the inlet pipe so that it avoids the submerge of the pipes. Having a small things like having a water pipe next to the inlet will actually help him cleaning of the pipes and even for himself. And also like in the picture we have shown, like how do we have better access for the operators to clear the solid waste block. Like sometimes it is too far that he can't get inside there, and then also even the T-pipe we have given. So all these are things that we are incorporating in our design. Say for example, having T-pipes like this in the middle so that he can actually remove, and if there's solid waste block, that can be removed. Those are the things we are incorporating in our designs from the point of operators. Yeah. Also, like in the planted drying beds, we have seen dried plants and there is no growth. Can we think about having some nurseries? Because again, procuring the plants for the planted drying beds again takes time. So can we have some kind of nurseries for the plant species for PDBs? And then if in case of ASR, if it is overloaded, to understand what is the load level, can we think about having some level sensors and it gives alert on overloading? Can we take the further load on all those things? And if the plant is full or if it is shut down, can we have some backup modules, a buffer to actually get more loads? If we cannot, if it is inevitable that we have to receive. Also, what we have the SOPs, we have the operation and manuals. What we have seen in the fecal sludge treatment plants is like once a handover procedure happens, that should also be done properly. Otherwise, like we have seen the manuals itself is not there, and the manuals is in English, operator will not understand. So we have actually developed the posters in the local language, and we have with the pictorial representation, which is very easy for the operator to understand, and that is put in the operator's room. And we are also developing videos in the local languages. Yeah, all these are from the perspective of operator. And one thing I personally feel is we always safely and wisely ignore the point of safety gears for the sanitation workers, for the operators. Those are actually not comfortable. So can we think of designing something like ergonomics to the operators so that he can work comfortably during hot seasons also? Yeah, and then definitely the uncertainties about his role, whether it is permanent, whether it is temporary, or delayed payments to the operator. All these are the motivation which is required for the operator to work with full mind. Yeah, so and then what I mean to say is SOPs we have for the technical issues for at the field levels, but I think there should be SOPs for all the actors, for the operators, for the ULBs, and all the actors who are involved. Yeah, it's a bigger, in the interest of time, I'm not talking about those actors, but these are needed. And also, I mean, we always also recommend to have a backup of the stock maintenance. All the required instruments at the field should be there, because these small details will actually affect the plan. So if one thing is not there and operator is waiting for the stock, all that will lead to dysfunction of the plants. Yeah. So the main focus is on how these operation and maintenance issues affects the output quality. If you see the effluent quality, this is the BOD that we have seen in one of the sites. We have seen the BOD was above the prescribed limits. And then what we have seen is in this particular site, there was overloading, and they were receiving the sludge from the hotels and restaurants and all that. So there is higher organic matter, lesser retention time, and then all that is leading to shooting up of your BOD level. And then again, in one of the site, we have seen the fecal coliforms was significantly higher compared to any other sites, and even compared to the specified limit. So here the ASR was under maintenance for a longer period. So it will actually affect the settling of your solids, and then along with the suspended solids, your coliforms will also move on to the effluents and so on and so forth. So all these are related to how your actually O&M issues are affecting the output quality. In case of sludge, what we have seen is in one of the sites, electric conductivity was very much higher. And here again, this is because this particular site was receiving the fecal sludge from the hotels and restaurants, maybe a combined FS with the grey water and the detergents inside. All those ionic compounds from these detergents would be shooting the electrical conductivity of the sludge. Yeah. So when we talk about long-term sustainability of FSTPs, yeah, I mean, we need to have proper design, proper construction quality, implementations, and operations all should be in place. And then if you see across the country, if the FSTPs are working well, all those FSTPs which are actually having simple operations are the ones which are working well, because there the operator knows what to do. Right. So it's important that way. And we need to have dedicated human resources and dedicated funds for operations. I mean, things we already know. Then we need to have collaborations with the truck operators, with the taluk panchayats, with the village panchayats, so that we can secure regular loads, have control on the loads. And also we need to explore IoT options, how we can automate operations, which will ease the operations at the site. And for the operator satisfaction, it is definitely a need to prioritize odor control and have that aesthetic feel, and then have the community participation across. So when we talk about resource recovery, we have seen most of the FSTPs where the sludge is piled up, and this is mainly because there's less engagement of the farmers, because they are the primary users, but then with the engagement with the FSTPs are less. And it's important that, like example, in Devanahalli, it took us a lot of time to engage with the farmers, and then a lot of hours was invested in terms of building their awareness, getting this trust through showing them the quality of the sludge with the certificates, demonstrating those results on the ground. It requires a continuous engagement. Yeah. And then also because it's a seasonal demand, so you need the sludge only during, especially for agricultural applications during monsoon and rabi season. How do we properly store it and then sell it during those seasonal time is important. So when we talk about resource recovery, from 2015 till here, we have done a lot of research and have actually implemented on the ground in terms of recovery. Why it is important? Because used water, if you use it actually meets because it is rich in nutrient content, it can actually meet almost 40% of the global fertilizer requirement, which is almost equivalent to $14 billion of revenue generation. And in case of used water, we see that low biological treatment processes actually eliminate the pathogens. There'll be more than 3 log reduction of pathogens compared to any other treatment systems. And even disinfection works well, but that is expensive. And that can be recommended for drinking water quality. So low biological treatments are more efficient in removing the pathogens. These are some of the cases where we have used the treated water for growing crops from vegetables. Simple things like having a polishing pond, growing the high growing crops, all that have actually reduced the coliform numbers. And we have also seen the nutrient content of the crop grown under treated water was higher compared to fresh water. Yeah, this is all published online, available. And then what is the rationale for using sludge? Coming to the sludge. Now, if you see our Indian soil is deficient in most of the nutrient content, essential plant nutrient contents, NPK and micronutrients, which is called the hidden hunger. So now how do we do? What do we do? If you, I mean, we have estimated the potential of fecal sludge. It is something that is published in the policy document where we said around 326 tons of urea per day can be replaced if we actually use the treated fecal sludge that is generated in India, and which can actually replace 42 million USD per annum of 4x saving. Yeah. So for this, what we have done is for Devanahalli, we have done the co-composting to eliminate the pathogen contaminations and to ensure there is proper nutrient balance. So there is
2 minutes, Girija.
Yes. So when we talk about composting, if it is done properly with the proper procedures, there'll be no leachate issues, there'll be no odor issues. So there's a proper procedure which we follow. And then the quality of the output which is coming from the compost was tested against the fertilizer control order, where our compost met most of the parameters per specifications. Yeah, and now it is bagged and sold to the farmers. And then this co-compost was applied to the field to understand how the crop growth and development and yield. What we have seen is co-composted has actually given higher yield compared to the treated sludge, compared to even the chemical fertilizer. So that because we are balancing the nutrient content, so it's important that we do co-composting. Another case was where we have used greenhouse solar dryers, which means the polycarbonate sheets over the drying beds, which will actually increase the temperature inside and reduce the relative humidity, which will in turn help in fastening the drying process and reducing the pathogens, especially helminthes eggs. So we have used IoT in this, like the sensors to take the real-time monitoring data of the temperature and the relative humidity of the ambient conditions and inside the chamber. What we have seen is that chamber temperature was almost 15 degrees Celsius higher compared to the ambient conditions, and it was even higher than the GI sheet, normal sheets. So during peak hours and throughout the day, it was 8 degrees Celsius higher, and there was significant drop in the relative humidity. All that has helped us in reducing the drying time. There was 40% reduction in drying time, and hence there was less number of beds and leading to less lowering the capex. And then there was the more than 90% of the samples tested were devoid of helminthes eggs. Yeah. And then we also continuously engage with the farmers. This is a recent farmers workshop that we had. Like this is very much important that if we want to enable resource recovery, it is important that we engage with the primary users, have continuous engagement with the farmers. Yeah, these are some of the publications. You can check all this online. They are available. Thank you so much for the time. Any questions? I'll be happy to take.
Thank you, Girija, for sharing some of the interesting research work that you people are doing. Very interesting. And also, when you start with the design philosophy, we should not build anything that cannot be maintained. There's a very interesting line. And seeing your last couple of slides on the reuse, then I'm just thinking whether we also add that we should not build anything that doesn't consider the reuse of the end products. This is a very important thing nowadays because biosolids are piling up and we do not know what to do with this given the policy norms we have currently. Very interesting. Thank you very much for your time, for your presentation. Now I quickly move to our next thematic presentation, which is around strengthening and sustaining operation and maintenance for fecal sludge and septic treatment systems in Tamil Nadu, enabling effective service delivery for environmental and public health outcomes. To present this, we have Srinithi Sudhakar and also Shashi Kumar Ishwarmurthy. Thank you for joining us, Srinithi and Shashi. And Srinithi is a governance and institutional specialist with more than 10 years of experience in the social and environmental project at IIHS, Indian Institute of Habitation Settlement. She supports the Tamil Nadu Urban Sanitation Support Program, working with government stakeholders to strengthen sanitation governance. And she also contributes to the development of safety standards for sanitation workers. Thank you, Srinithi. And also we have Shashi Kumar, who is lead practice water sanitation at IIHS. He is a civil engineer by training and has more than 18 years of experience in the water supply and sanitation sector. As part of the TNU SSP program, SOSI focuses on the engineering, planning, and implementation, and has been closely involved in the construction management, quality assurance, and performance monitoring. Over to you, Srinithi and Shashikumar. Please share your insight. Thank you.
Hello everyone, hope you can hear me. I am Srinidhi Sudhakar.
Yes, you can.
Thank you. I'm Srinidhi Sudhakar and I work with IHS. So before we get into the core content of the PPT, this slide actually summarizes all the key areas of work that will be made in this presentation. So this is just for your purview. And I will be setting the context to this presentation. So since we have varied number of participants from different countries as well, so I will quickly mention the sanitation context in Tamil Nadu. What is the status of sanitation in Tamil Nadu? And then the program which they mentioned, the Tamil Nadu Urban Sanitation Support Program, what is the approach behind it? And what was the approach behind scaling of treatment facilities in Tamil Nadu? So as you can see in the slide, like many other states in India, in Tamil Nadu as well, many of the urban households were very dependent on on-site sanitation systems. So Government of Tamil Nadu in 2014, they issued operative guidelines for septage management. And then in 2015, the Tamil Nadu Urban Sanitation Program was initiated. And we started helping the government in implementing FSM interventions across the state. So the program, the Tamil Nadu TNUSSP program is the acronym which we use. So the Tamil Nadu program was executed in 3 phases. In the first phase of the program, we were demonstrating FSM innovations and interventions in model locations. One was Tiruchirappalli Corporation, which is in Tamil Nadu, and then 2 other smaller town panchayats as well in Tamil Nadu. One is Narasimhanaikenpalayam and another is Periyanaikenpalayam. So in Periyanaikenpalayam, we have the first mechanized treatment facility in Tamil Nadu, which is successfully operational till date. And in the second phase of the program, the focus was on scaling treatment facilities across the state. And I think Sasi will now further go into detail on how we scale treatment facilities across the state, starting from construction to operation. And in the third phase of the program, we focused on how to strengthen and sustain these treatment facilities, not only treatment facilities, but all the FSM interventions which were taken as part of this program. The efforts to strengthen and sustain operation of treatment facilities, we will touch upon very briefly at the end of the presentation, and then we will close it. Okay, over to you, Sasi.
Scaling treatment. I am Sasikumar from IHS. Scaling treatment is important. So in Tamil Nadu, to avoid open disposal, establishing treatment facilities is an important role played in Tamil Nadu government. So Tamil Nadu focus on using a cluster approach. Existing facilities, how to utilize the existing facilities, and proposed facilities, how to manage that cluster approach. The 2 strategies are followed in Tamil Nadu government. Next slide. Next slide, see. So, state investment plan, we planned phase 1, 2, 2, 3, 4, 5. So phase 1, 2 are existing facilities, STPs, how to initiate co-treatment. Phase 3 is creating new fecal sludge treatment plant. Phase 4 and phase 5 is land. Land is not, that time is not available when we are prepared in 2018 state investment plan. So now they are SBM 2.0, STP become FSTP for phase 4 and phase 5. And also we are focusing on rural also. Urban rural cluster also mapping we done. Almost 12,525 village panchayat planning to cluster with urban local bodies. Now around 3,000 village panchayats are clustered in phase 1, 2, 3. That initiative also going on. This is next slide. So this is our phase 1, 2, 3 cluster map. Then 4 and 5 cluster map is now ongoing. Total overall phase 1 to 5, the cluster map is shown in figure. Next. So initially, that all FSTPs are in Tamil Nadu co-located in solid waste management site. So why means that after that treated sludge which co-compost to solid waste. So that is the initial plan. That's why we proposed FSTP located in SWM site. Next major is design. Design is we plan for modular approach 20, 30, 40 KLD. Wherever land is available, we are going for a gravity-based system. Land available is less means we are going to mechanized system. That is initial design we planned. And also solid waste management, who will maintain the sanitation workers, that person should maintain to FSTP also. So that's why not different technologies are not using. Normally same simple technology only we are used. Next. So this is the gravity-based system. So in everywhere in Tamil Nadu, most of the location we are using this gravity-based system only. So screen chamber, mainly we are focused on screening incoming fecal sludge. So in Tamil Nadu, most of the locations are industrial area. So that's why we are mainly initial screening protocol is important. Once sludge we receive, that pH, EC and colors and adores if it is there. So we checked, then only we allowed for the unloading. So if gravity-based this biological system, if entered in industrial load means the entire plant will be affected. That's why screening protocol we framed so that each will be following that screening protocol. And also regular removal for solid waste. And also screening chamber is daily and weekly we need to clean. That activities also we are following. And that protocol is important. We circulated for each ULB for that how to maintain that screening protocol that we will share with the team. Then stabilization reactor, periodic emptying is important. If floating materials passed to stabilization reactor means that pumps and all will be very frequently choked. That's why that screening is important. Then emptying last chamber is important for desludging. Emptying last chamber is important for to avoid the sludge to enter in solid particles enter in the drying bed. Uniform distribution loading is important for drying bed. That also we are monitoring and monitoring drying times. So monsoon time and summertime, how to that sludge variation rating we are following. And also we are using polycarbonate roof for sludge drying bed. So that sludge drying time, it will be reduced for using that polycarbonate sheet. And integrated settler anaerobic filter, periodic blockages is we are once we are maintaining that time, we observe that. So that clogging for that filter media is frequently happen. So we are continuously that first two chamber we are desludging. If it's happened once in 6 months, that clogging it will not happen. That also we that activities also we included in that. So polishing plant, so horizontal planted gravel filter, we continuously cut it, that trimming and for the plants growing and monitoring the flow, cleaning gravel bed when it is required once in 6 years. That time that are the main activities for horizontal planted gravel filter. Polishing pond, controlling algae growth and monitoring water quality is important for that polishing. This and all activities are we are following for gravity-based system. Next slide. Next. So the standard operating procedure for O&M, we are preparing. We developed standard operating procedure for gravity-based system and mechanized system. So, and also we are following key performance indicators for FSTP maintenance that in all over state, that SBM team also now is there. So they are following that key performance indicator for regularly and continuously. And also that O&M operating procedures are included daily, weekly, monthly task, operational logs and emergency response protocols, everything in mentioned that in our O&M protocol. So, and also frequently we are giving capacity building training for 6 months once. Some ULBs are, we are training cross-learning also. Good performance ULB, we bring other ULBs get it into that good performance will be. They will training for institutionalists also we are doing for that training and all everything. So that also happening. And safety are strictly enforced through guideline we mentioned in the PPE definition, disinfection routines, and equipment inspection and everything is provided in the operating procedure. Next. What are the challenges we faced in gravity-based system? So mainly that initially screen chamber using the FS, so that desludging operators come and unload immediately. So short span, so span of the time. They will unload. So we reduce. We normally for unloading desludging vehicle, it will take 1 minute. So we that. Major issues overflow for the screen chamber, and also that overflow material send into stabilization reactor. This affect pump and also grid accumulation, everything is happened. That's why we are fixing that timeline. So once discharging operator comes to treatment facilities, it will take 7 to 10 minutes. Proper control discharge is regulated. It will not affect SR and overflow and accumulation grid, everything will be controlled. This and all we challenges faced and also we addressed. And stabilization reactor, once this first screen chamber is controlled everything, the stabilization reactor get it not get it for floating material and everything. So that also regularized, and the pump choke and everything is sorted out. Initially, for when we are starting 2008, we are faced a lot of issues that the plant operator don't know for how to unload and everything. So this challenges and all whatever we mentioned in the deck, this is we faced. After that, this also we addressed for based on our learnings, experiment, and we controlled and addressed this every challenges for the FSTPs. Now it is almost running successful. Next. One of the technologies, next slide. So before, this is a mechanized system. What Srinidhi mentioned, Perinag and Palyam, we implemented for this mechanized FSTP. So this land also very less, 500 square meters only required for this FSTP. So now initially we constructed through program 25 KLD. Now that plant is augmented for 50 KLD, and also state also scaled for that mechanized FSTP. Furthermore, 4 locations were implemented. Now that also is running successful. So this is mainly in gravity system, solid liquid separation for drying bed. Here we are using for volute press for solid liquid separation. Here first screening chamber, then storage tank. After that, solid liquid separation, we are using dewatering unit. Then solid liquid separation. After that, solid separate send it to co-compost with municipal solid waste. Then liquid streams goes to moving bed, MBBR technology only. So here initially facing lot of problem. So here mainly we in that gravity system, whoever want to see easily maintained. This mechanized system, some experienced person only should maintain. So we face challenges for person who will maintain the plant. So that also we given training for some lot of people, and we procure some diploma holders and IT failed person. So that kind of person we procure and we trained, then only that plant operation will be successful. So yeah. So here this same maintenance activity is also we are following here. Here also we are putting standard operating procedure. Next slide. Next. So way forward. So previously we said capacity building and preventive maintenance protocols, infrastructure design improvements, and resource provision and safety, monitoring, supervision, and waste handling and end use strategies we are using. And also we are focusing on co-composting also FSTP. Around 10 ULBs are now co-composting is introduced and practicing also. Next. And this is after FSTP co-treatment also happening. We have two type design. One is for pumping station. One is for STPs. This two type design based on site condition we categorized. Wherever space available, it will go to type design 1 or type design 2. These are also ULBs are following. Next. And sampling that co-treatment decanning station. Mainly, we are seeing for spillage management, vehicle GPS installation, and FS screening protocol, and after safety and health, and screening frequently remove. This is under to-do list for decanning facilities. Next. So, current status. Tamil Nadu have 51 FSTPs. In that, 41 FSTPs are now operational. Around 2.3 million people are serving that treatment facilities. Another 10 plants covering an additional 1.1 million that are nearing completion. Co-treatment of fecal sludge, existing sewage treatment plants are already in placing 48 ULBs, benefiting 8.3 million residents. Plans are mentioned. Now another 11 locations also co-treatment facilities implemented. Average load receiving per day, all STPs range between 800 to 850, and FSTPs also we are getting 30 to 35% utilization all over state. This is under current status. Next. Shini.
Sorry. So I'll just quickly summarize again what is required for strengthening and sustaining these FSTP operations. Like already we mentioned that many PPTs before also it has been mentioned that utilization of these treatment facilities is very important. That is to increase the utilization and maintain optimal utilization. So that for that we adopted an approach called regulating of desludging operators to make sure that these desludging operators are regulated and they are streamlined to safely dispose at these treatment facilities. So a licensing agreement was put in place. So this licensing agreement focused not only on getting them registered with the ULBs to ensure safe disposal, but it also looked at other aspects such as health and safety for them, insurance for them, and all that. So in terms of occupational safety, we had this So in terms of occupational safety for desludging operators or sanitation workers in whole, we looked at this approach through a system syncing approach. We adopted this hierarchy of controls table, which you can see out here. So in this, we focused not only on PPE, we felt that protection of PPE is only the last method for protection. But before that, we focused on many other steps, that is prevention. So a lot of awareness programs were done for desludging operators, sanitation plant operators, to make sure that they do not use any hazardous equipment, and also to make sure that they move from manual to mechanical methods. And in addition to that, in terms of mitigation measures, like Sasi had already mentioned, like we also made improvements in the co-treatment facilities, decanting facilities to make spillage management, to avoid contact of fecal sludge with these operators. That was another thing. And also improving designs to truck designs so that they do not come in contact with fecal sludge either while collection or while disposing at the treatment facilities. And then in terms of mitigation, we have also prepared standard operating procedures for desludging processes. And we've also done a lot of first aid trainings with the different sanitation workers to equip them to handle any emergencies. And finally, protection, that we all know that PPE is very important and it is not enough. It's very important that we design a very user-friendly PPE for these people. So that is another key issue that we worked on. And in terms of sustaining operations, again, like Sasi told, we've initiated urban-rural clustering to increase utilization of these treatment facilities. And also we work with the government in getting a directive out so that all these community public toilet loads are directed towards all these treatment facilities to increase utilization. And then also different capacity building, which Sasi had mentioned about, like, whether classroom trainings or exposure visits or peer learning, or even online
you have to
audio.
stop, Sunitha.
Yeah, that's it. That's the last thing.
Mhm.
So yeah, so these were some of the sustaining for strengthening and sustaining in terms of assigning responsibility and also ensuring that funds are there to run these FSTPs, especially in smaller ULBs. Yes.
Thank you, Shashi. Thank you, Srinidhi. I understand the time allotted is not that great. It's only 15 minutes of time. However, you have taken 18 minutes of time. Anyway, thanks for sharing the scaling up journey of TUNU SSP, how the entire state is brought under operation and coverage, and how rural-urban convergence is also taken care of through phased steps. And you have also shared how SOP is being followed in operation and maintenance of your FSTPs. And also the last couple of slides are also very crucial, which talks about occupational safety, health and safety of sanitation workers, and especially the three-phased approach, which is prevention to mitigation to protection. These are very important steps. Thank you for sharing everything. So we are at the end of our webinar today. If we have one, two questions that we can take, Shukanna or Harsh, we can quickly take 1-2 questions, and then probably we'll respond to those questions and we'll close then. Is there any questions? Has anyone raised their hand?
So I think some of the questions were answered online or through chat, but we don't see any hand raised right now.
Okay.
If participants have any questions, they can raise their hands. Subhash.
Yes, very quickly. Yeah.
So you can unmute yourself and ask a question, Mr. Subhash.
Sir, good afternoon.
Yeah, please carry on.
Sir, I'm Subhash Reddy from Hyderabad.
Yeah.
I'm looking for a practical model for a girls' residential school for around 300 students. It's a residential school. There's a sewage, stagnation. So they have a sufficient place for the treatment, the method. Please help us in getting the model for doing this, implementing this treatment.
Yes, sir. So the topic of today's discussion is slightly different, but anyway, you can forward your request through a formal mail so that we can respond it properly, and through our partners across the states, we will see how this can be addressed. Right? You have my email ID. You have our email IDs. We have shared this. So anyway, I in question answer section also I have given my email ID. You can write to us. Thank you.
Acha, right.
Next.
Thank you, sir. Thank you.
Okay, welcome. Next. Is there any question?
We don't see any hand.
Okay,
raised.
fine. Thank you. Then let us close this discussion. Before closing it, I would really like to thank Hari, you, Harsh, Girija, Suniti, Shashi, those all the speakers who are coming with great field level experiences, knowledge. This is not bookish knowledge, but knowledge coming out of practical experiences, dealing the plants, dealing the stakeholders, training the stakeholders, addressing the regular challenges that are coming from the fields. So thank you, all of you, Girija, Smriti, Shashi, for taking out time to be part of this webinar. Thank you very much. And also I thank you many people who have joined today's discussion. I know this is a very technical session and it's not easy to be part of the discussion, but still we see lots of people remain part of discussion. We look forward to see you again. We look forward to engaging with you again. Thank you very much for the discussion. So Harsh is requesting to open everyone's camera so that you can take a photo. If you are available, you can please open your camera. We can close it right now. Hori, Shikanna.
Sure, sir. Thank you.
Thank you. Bye.
Sure.